Welcome to sixth grade math. Get ready for the lesson. A movie theater's concession stand is shown. List all the possible ways to choose a soft drink, a popcorn, and a candy. So there are 3 soft drinks, 3 popcorns, and 2 candies. So if we make a table, we have jumbo soft drink, giant popcorn, licorice candy. We have jumbo large and licorice, jumbo small licorice, jumbo giant chocolate, jumbo large chocolate, and jumbo small chocolate. Now let's look at combinations for our large soft drink. So we have large giant licorice, large licorice, large small licorice, large giant chocolate, large chocolate, and large small chocolate. And now let's look at the combinations for a medium soft drink. We have medium giant licorice, medium large licorice, medium small licorice, medium giant chocolate, medium large chocolate, and medium small chocolate. How do you know you have accounted for all possible combinations? By making an organized list, I know there are 6 combinations that include a jumbo drink. Since this is true for large and medium drinks, I know that I must have 6 times 3 or 18 possible combinations. Sample space, the set of all possible outcomes in a probability experiment. Lists and tree diagrams can be used to find sample spaces. A tree diagram is a more organized form of a list. Knowing the sample space of an experiment makes it possible to find a probability that an event will occur. The sample space for choosing a marble and the sample space for picking a card are shown at the right. So there are 6 marbles, red, blue, orange, purple, green, yellow, and 4 cards. So we're going to make a list to see what the chances are of pulling each marble, each color marble with each card. And you can make a list to determine the sample space. So we have a red marble with each card, so red and card 1, card 2, card 3, card 4. And then we make a list of the blue marble with each card, the orange marble with each card, the purple marble with each card, the green marble with each card, and the yellow marble with each card. So if there are 4 possible scenarios or 4 possible cards you can pull with each color marble, and there are 6 marbles, we have 24 possible outcomes. Scaffolding questions. We have green shorts, black pants, a white t-shirt, and a yellow tank top. What outfits can you make with green shorts? You can make green shorts and a white t-shirt, green shorts and a yellow tank top. What outfits can you make with black pants? Black pants and a white t-shirt, black pants and a yellow tank top. How many outfits in all could you create with these clothing choices? 4 choices. Use a list to find sample space. Assemblies. The 3 students chosen to represent Mr. Baldrick's class in the school assembly are shown. So we have Adrian, Carlos, and Greg. All 3 of them need to sit in a row on the stage. And how many different ways can they sit in a row? Make an organized list. Use A for Adrian, C for Carlos, and G for Greg. Use each letter exactly once. So we have Adrian, Carlos, and Greg. Adrian, Greg, and Carlos. Carlos, Adrian, and Greg. Carlos, Greg, and Adrian. Greg, Adrian, Carlos, and Greg, Carlos, Adrian. There are 6 ways that students can sit on a stage. Check your progress. Use a list to find sample space. How many chicken and sauce combinations are possible if you can choose from crispy or grilled chicken with ranch or barbecue sauce? So make an organized list. We'll use C for crispy, G for grilled, R for ranch, and B for barbecue. So we have crispy ranch, crispy barbecue, grilled ranch, grilled barbecue. Or we can make an organized list to show the sample space using a table. So we have crispy ranch, crispy barbecue, grilled ranch, and grilled barbecue. Tree diagram shows all possible outcomes of an event. Example, use a tree diagram to find sample space. Use a tree diagram to find how many ice cream cones are possible from a choice of waffle cone or a sugar cone and a choice of chocolate mint or peanut butter ice cream. List each type of cone first. So cone, we have a waffle and a sugar. List each type of ice cream. Ice cream flavor, we have chocolate, mint, and peanut butter. Chocolate, mint, and peanut butter. And now we'll list the outcomes. So we'll list each combination. We have waffle cone and chocolate, waffle cone and mint, waffle cone and peanut butter. Then we have a sugar cone and chocolate, sugar cone and mint, and sugar cone and peanut butter. There are 6 possible ice cream cone combinations. Check your progress. Use a tree diagram to find sample space. Use a tree diagram to find how many words can be made using the words fast, slow, old, and young, and the suffixes and est. So the words are fast, slow, old, suffixes est, 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 and then the outcomes faster, fastest, slower, slowest, older, oldest. The fundamental counting principle is a principle states if there are m outcomes for a final choice and n outcomes for a second choice, then the total number of possible outcomes can be found by multiplying m times n. Real-world example using the fundamental counting principle. Casey's Pizza House offers the choices shown in the table. Use the fundamental counting principle to find the total number of possible outcomes for a one-topping pizza. So we have 3 different kinds of crust, and we have 6 different types of toppings. So the number of outcomes for the crust is 3, and we'll multiply that times the number of outcomes for topping, which is 6. And that's going to equal the total number of outcomes. So 3 times 6 is 18. And you can check by drawing a tree diagram to show the sample spaces. So you would have 3 initial options, and each one of those 3 would have 6 off of it, the toppings. So that would equal 18. Check your progress using the fundamental counting principle. A number tube is rolled in a spinner with 4 equal sections marked A, B, C, and D is spun. Use the fundamental counting principle to find the total number of possible outcomes. So there are 6 possible outcomes from the number cube, and there are 4 possible outcomes from the spinner. So if we multiply the 6 times 4, the total number of outcomes is 24. And you can check by drawing a tree diagram to show the sample space. So if you did, you'd have 6 of the initial. So 1, 2, 3, 4, 5, 6. And then you would have 4 off of each number for letters A, B, C, D off each letter. Additional examples, use a list to find sample space. Vacation. While on vacation, Carlos can go snorkeling, boating, and paragliding. And how many ways can Carlos do the 3 activities? Make an organized list to show the sample space. So if we make an organized list, use S for snorkeling, B for boating, and P for paragliding. So the first combination is snorkeling, boating, paragliding, then snorkeling, paragliding, boating, boating, snorkeling, paragliding, boating, paragliding, snorkeling, paragliding, snorkeling, boating, paragliding, boating, snorkeling. Or we can make an organized list to show the sample space using a table. So that's what our table would look like. And use a tree diagram to find sample space. A car can be purchased with either 2 doors or 4 doors. You may also choose leather, fabric, or vinyl seats. Use a tree diagram to find all the buying options. So the car is either 2-door or 4-door. And the seats are either leather, fabric, or vinyl. Then we'll have the same options for a 4-door. And the outcomes would be a 2-door leather, 2-door fabric, 2-door vinyl, 4-door leather, 4-door fabric, 4-door vinyl. Use the fundamental counting principle. Chloe wants to buy a bouquet of flowers and a vase. The flower shop has roses, daffodils, and tulips, and has 4 different vases from which to choose. Use the fundamental counting principles to find the total number of possible outcomes of a bouquet made up of one type of flower and a vase. So the number of outcomes for flowers, there are 3 different types of flowers, and times the number of outcomes for vases, so there are 4 vases. If we multiply 3 times 4, the total number of outcomes is 12. And you can once again check by drawing a tree diagram to show the sample space. There is your homework for tonight. Head to Google Classroom to submit it. And I hope you have a great night. I will see you in class. Thank you.